ELECTRO-TECH UG. Current technology. Future excellence.
You are most welcome to ELECTRO-TECH UG, your go-to channel for electrical repair, maintenance, and eco solutions. Today we are diving into how to repair an automatic voltage switcher, also known as an AVS. But before we dive into today's project, you have to know that an AVS protects your electrical appliances from voltage fluctuations by disconnecting power, that is, if voltage goes either too high or too low depending on set parameters. It then restores it when voltage stabilizes, and this is essential for protecting your devices like TVs, fridges, ACs, to mention but a few. Before opening your device, make sure that you isolate it from power and use insulated tools. Now that we've opened up our device, we are going to do a visual inspection on all components on our PCB layout. We have to check for the fuse, the capacitors, the IC itself, the relay, the LED indicators, the potentiometer, that is the delay timer, the blind voltage timer, and as well as the voltage set potentiometer. After troubleshooting, I realized that I had a burnt fuse on my circuit board, and as well as 3 of the LED indicators had gotten spoiled. So I had to use the previously shown circuit boards that had working components and as well as faulty ones to swap and make one perfect. So if you have any, that's why as lecture engineers we always keep and don't throw away such boards. So I used that as a chance to repair one from the circuit boards. Having done the repair, we had to subject our AVS to certain loads. Like for example, we used a percolator to carry out this test. Remember, the maximum current rating of this AVS is 30 amps. So as well, be mindful of the cable size that you are going to use, and as well rest the circuit board on an insulated surface, otherwise there's risk of electric shock. Mind about the polarity before connecting your loads. To know that you've used an undersized cable, it will overheat and as well deform. You always smell a burning wire or cable. So that's one way of detecting, as we've demonstrated in the video. We experienced this during our test, so be mindful of that. For short cable runs, you can use 2.5 mm squared copper, but for longer runs, 4 to 6 mm squared is recommended. When the AVS passed the test, I had to take it back to the protected equipment, and this time around was a freezer. I had to set the desired parameters like the wait time, the blind voltage time, and as well as the operational voltage limit, and then sit back and watch the appliance turn on. I hope you've learned something. See you in the next video. I remain ELECTRO-TECH UG.